Section 13.1 talks about linear measure. So in this section, students will be able to understand and explain the English system of linear measures, the metric system of linear measures, conversion among measures, something called dimensional analysis, perimeter and circumference, and ratios of linear measures of similar figures. So the English system, in the United States we use the English system because we use things like feet, inches, and yards. And so what we're going to do is we're going to do some conversions here. So we want to convert 164 inches into yards. And we're going to do that by using something called dimensional analysis. So the first thing I'm going to do, I'm going to write a fraction. And I'm going to write the number that I have. So we have 164 inches, and I'm going to write this over 1. See if I can get this a little bit bigger. There we go. Okay, and I'm going to multiply it by another fraction. And eventually what I want to get to is I want to get to yards. So what I'm going to do here is I'm going to look at a relationship between inches and yards and see if I can't figure this out. Okay, so I know that 12 inches is the same thing as 1 foot, and we know that 3 feet is the same thing as, say, 1 yard. Okay, so if we know that 12 inches is 1 foot and we know that 3 feet is 1 yard, what I want to see is, can I figure out a relationship between yards and inches? Well, yards is 3 feet and this is 1 foot. So if we were to multiply, say, this part here by the number 3, then we would end up with 36 inches is the same thing as 3 feet, and we know that 3 feet is the same thing as 1 yard. So 1 yard is the same thing as 36 inches. So I'm going to write down my number 36 down here, and I'm going to write 1 yard here. Now what I want to show you is that whatever units I have here, I'm also going to put them on the bottom. And then whatever units I want to end up with over here, that's going to be the one that's going to go here. Okay? All right. So now what's going to happen? These units, inches and inches, one's on the top, one's on the bottom, those are going to cancel. Then I'm going to multiply. 164 times 1 is 164. Come on, pen. 164. And 1 times 36 is 36. And then I'm just going to take my calculator here, turn it on, and clear it out. And I'm just going to take what's 164 divided by 36. And I'm coming up with 4.555555. So 4.555, and I might write 4.56, or, let me see, 36 into 164. Well, we know it goes in 4 times, right? So 4 times 6 is 24, and 4 times 3 is 12, plus another 2 is 14. And if I subtract, I have a remainder of 20. So I might write it also as, let me move this over to the side, 4 and 20 over 36, but I can reduce this part of the fraction. Can divide them both by 4. So 4 and 5/9 yards. Okay. All right. Let's see if we can do the same thing for the next one. So now we're going to go from 340 yards into inches. Okay. So part B says let's take 340 yards and we're going to convert that into inches. So again, I'm going to think of this over 1. Okay. I'm going to multiply by a fraction. Now again, remember, if I have yards here, I want to put yards here. If I have inches here, I'm going to put inches on top. Now we already came up with a conversion. We said that 36 inches is the same thing as 1 yard. So 36 inches is the same thing as 1 yard. So these yards and these yards are going to cancel, and then all I'm going to do is just multiply those two numbers together. So move this over here, clear it out. 340 times 36, 36. And I'm coming up with 12,240 inches. 12,240 inches. All right, now let's see if we can do part C. Part C says, can we convert 720 feet into yards? So I'm going to think of 720 over 1 times, now again, I'm going to multiply by a fraction. So again, just a quick reminder, look, if I have feet on the top here, feet are going to go on the bottom here. And if I have yards over here, then yards are going to go right there. And we know from this piece right here that 3 feet is the same thing as 1 yard. Okay, so let me move this up a little bit. So 3 feet is the same thing as 1 yard. So these units of feet are going to cancel. I'm going to multiply straight across. That's going to give me 720 over 3. Let me take my calculator. 720 divided by 3. And we come up with 240 yards. Okay. All right. And we do have a part D. So part D says, can we convert 444 inches into feet? Okay, into feet. All right, so let's think of this as 444 over 1 times, I'm going to write a fraction here. Remember, if I have inches here, I'm going to put inches here, and if I have feet here, I'm going to put feet here. So we know that 12 inches is the same thing as 1 foot. So again, these units of inches are going to cancel. We're going to multiply straight across. That's 444 over 12. Let me grab my calculator again. Let's move it this way. Divided by 12. Let's see if it goes in nice and neat. It does, and we end up with 37 feet. Okay. All right. So here's another problem. It says if a cheetah is clocked at 60 miles an hour, what is its speed in feet per second? Okay. So I'm going to write this down here. We have 60 miles per hour. And we're going to multiply it by something, and we want to end up with feet per second. Okay. All right. So in this part, we're going to do a couple of probably conversions here. So I'm first going to figure out, how do I convert miles to feet? So if I have miles here, I better put miles here. And if I have feet there, I better put feet here. And according to our chart, let me get our chart, here we go. 1 mile is the same thing as 5,280 feet. Okay, so 1 mile is the same thing as 5,280 feet. Okay, so that's going to take care of converting our miles to feet. Now, the other part we need to convert is we need to convert hours to seconds. Okay. So if I'm going to convert hours to seconds, I know a couple of conversions. I know that 1 hour, let me see if I can write this over here on the side for a little bit. I know that 1 hour is the same thing as 60 minutes. And I know that 60 seconds is the same thing as 1 minute. So I want to see if I can find a conversion for 1 hour to seconds. Okay. So if I were to take this expression here and multiply it by 60, okay, 60 times 60 would give me 3,600 seconds equals 60 minutes, but I know that 3,600 seconds, I know that 60 minutes is the same thing as 1 hour. So 1 hour is the same thing as 3,600 seconds. Okay. So notice where we have our hours. We have it on the top, so I'm going to put 1 hour here, and I'm going to put 3,600 seconds here. Okay. And then I'm just going to multiply, and it's going to take me a little bit of time, but that's going to be okay. So first thing I want you to notice is, let's see, Miles and miles are going to cancel out. Hours and hours are going to cancel out. And we'll be left with feet per second. So now we're going to multiply straight across. Okay, so I'm going to take 60 times 5280 times 1. So let me do that over here. And move this a little bit and try it again. Okay, so 60 times 5,280 times 1, that's going to be the same thing, right, is 3,000 or 316,800. So 316,800. 316,800. Okay? And then I'm going to multiply my denominators. Remember, the denominator here is 1. So 1 times 3,600 is, well, 1 times 3,600 is still 3,600. Now I'm going to take my calculator and I'm going to divide those numbers out. So let's divide it by 3,600. Okay? And we're coming up with 88. So my answer here would be 88 feet per second, right? So all we did is divide those, and we got our nice pretty 88. Okay, so again, one thing I really want to mention, you can see there's quite a bit of conversions that we have to do. Okay. All right, and so we have the metric system next. And in the rest of the world, they use a metric system. We're the only ones that use the the English or the US system. But kilo is means 1,000, and their symbol is K. Hecto, we use the symbol H, 100. Deca, we use the symbol DA, it's 10. Deci, we use the symbol D, and it's 0.1. Centi, we use the symbol C, and it's 0.01. And milli, we use the symbol M, and it's 0.001. So to give you an idea, what is 0.1? This is 1/10. This is 1 over 100, and this is 1 over 1,000. Okay, so here's just kind of like an example. A kilometer means 1,000 meters. A hectometer means 100 meters. A decameter means 10 meters. Meter would be my base unit. A decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter, and a millimeter is 1/1000th of a meter. Okay, and so here we have some benchmarks for metric units. So a meter is about from one shoulder all the way out to the end of your finger when you have your hand, your arm extended. A decimeter would be about the width of your hand. A centimeter looks like it's about the width of your fingernail, and a millimeter is about the thickness of a paperclip. Okay, so I'm going to show you how to do some of these conversions, and this little table right here gives me a whole lot of information. Okay, so I'm going to show you how to use this table. So look, we have 37 centimeters, and I want to write it as millimeters. So I'm here right now, right? I'm at centimeters. I'm at centimeters. I'm going to move one space over to millimeters. What I want you to think about, the number 37, my decimal, even though I don't see it, is at the end, okay? If you notice, from going from centimeter to millimeter, I went one space to the right. So I'm going to move my decimal one space to the right. That means I need to add a 0 here. This is 370, okay? Now, I want to go back to meters. So let me do this part again. Let me erase this, write it down again, 37. Remember, my decimal is right there. I want to go from centimeters to back to meters. This would be like my basic unit, okay? So look, I'm going to count 1, 2. So I'm going to go 1, 2. So where are we now? 0.37, okay? The height of a woman, 1.65 meters. Okay, so let's do that again, 1.65. And let's see where we are, and let's see where we want to get to. Okay, so right now we're at meters, and we want to move 2 spaces to the right to get to centimeters. 2 spaces right, this would be 165 centimeters. And if I wanted to get to millimeters, I'd have to move one more decimal place, so I'd have to put it here. And so then this number would be 1650. Remember, I got to add a 0 in at the end. Okay. All right, so let's see if we can do the next one. And I'm going to keep using this little chart here, guys. In this little chart, depending on which way I'm moving, if I'm moving to the right, I move my decimal point to the right. And if I move to the left, I'm moving my decimal point to the left. So look at the number we have. We have 34 millimeters, right? My decimal point, if I don't see it, is at the end. I'm at millimeters, and I want to go to centimeters. So I'm moving one space to the left. So this would be 3.4. And for millimeters, if I wanted to get back to meters, 1, 2, 3. So here's 1, here's 2, here's 3. What do I need to put there? A 0. It's supposed to be a point right there. Okay, length of a cigarette. Let's do the same thing again. Don't smoke, guys. It's not good. And if you know anybody that smokes, try to get them to quit. It's not good for us. Right? Okay. I used to, and I quit, I don't know, about 17 years ago. So I feel much better. All right, so we're at millimeters, and we want to go to centimeters. So I'm going to move one space to the left. So this here is going to be 10.1. And then from millimeters, I'm going to go 1, 2, 3. So 1, 2, 3. So 0.101. Okay. And the next one, the length of 6 meter sticks laid end to end. Okay, so we have 6 meters, right? Here's 6. And let me erase this mess here. Let's do this again. And we're going to go from our basic unit of meters to 1, 2 to the right. So 1, 2 to the right, I got to put 2 zeros. This is 600. And if I move one space more, I got to add another 0. So this is going to be 6,000. Okay. So I hope that you find using this little chart helpful. And it allows me to figure out how I'm going to move from one spot to another. Okay. All right. So the next part here, we have something called distance properties. And it says the distance between any 2 points A and B is greater than or equal to 0. And it didn't come out here, but this right here, it's supposed to say AB is greater than or equal to 0. And it says the distance between 2 points A and B is the same as the distance between the points B and A. So they're equal, right? And then it says for any 3 points, A, B, and C, the distance between A and B plus the distance between B and C is greater than or equal to the distance between A and C. So again, this little symbol didn't come out here. All they're saying here is that AB plus BC is going to be greater than or equal to AC. Okay? And so we have the triangle inequality. And the triangle inequality says the sum of any lengths of any two sides of a triangle is greater than the length of the third side. And let's see. It says, can a triangle be made with sides that are 15, 18, and 37? So we're going to say that 37 is going to be the bigger, it's obviously the biggest distance. So we're going to add up these two here. So when I take 15 and 18 and I add them together, I get 33. And that is supposed to be bigger than the third side. So is this possible? We would say, no, it's not possible. Okay. So in these type problems, when you have something like this, you're going to take the two shorter sides, add them together. If that number is bigger than the third side, then we're good. And if it's not, then it can be a triangle. Okay. All right. So it says two sides of a triangle have lengths 21 and 98. The measure of the third side is a whole number of centimeters. What's the longest that the third side can be, and what is the shortest that the third side can be? Okay, so let's assume that the third side, we're going to call it x, okay? And because we know that of the triangle inequality, that when we add up two sides, it has to be bigger than the other side. So I'm going to take 21 plus 98, and that's supposed to be greater than x. Or I might say, what about 21 plus x, and that might be greater than 98. Or I might have 98 plus x, and that would be greater than 21. So I basically have three inequalities here, and I want to solve each of them, okay? So the way I solve an inequality, same way I solve an equation. I'm just trying to get the x by itself. So when I take these two numbers and we add them together, that's going to be, what is that, 119? So 119 is greater than x. Let's see. Okay, so now, so when I look at this, 119 is bigger than x. This is saying the same thing, that x is smaller than 119. Okay? So here I'm going to subtract 21 and I'm going to subtract 21. And this is telling me that x is bigger than, if I subtract here, that's 7 and that's 7. So x has to be bigger than 77. Okay? And when I subtract 98 from here, x has to be bigger than, this is going to give me, actually, let me see. Let me take my calculator. What is 21? Oops, turn it on. What is 21 minus 98? And negative 77, right? Negative 77. Okay. So we know it's not going to be this because x has to be positive, right? So I want you to think about what this is telling me. If I look at this one here and this one here, this is telling me that x is bigger than 77. Another way I can write this is that 77 is smaller than x. But I know that x is also smaller than 119. Okay? So this is telling me that x is going to be bigger than 77, but smaller than 119. Okay, so smaller than 119. So if x has to be a whole number, the next smallest number that is smaller than 119 would be 118. And if x has to be bigger than 77, and it's going to be a whole number, the next whole number that's bigger than 77 would be 78. Okay? All right. So now we have something called the circumference of a circle. And it says, a circle is a set of all points in a plane that are the same distance from a given point, called the center. The circumference is referred to as the perimeter, the distance all the way around that circle, okay? And pi is the ratio between the circumference of a circle and the length of its diameter. And a lot of times we use these sort of abbreviations for, or these approximations for pi. Okay, so we have two formulas here. One of them is pi d, and the other one is 2 pi r. And it says, for each of the following circumferences, find the radius of the circle. Okay, so in part A, we know that the circumference is 12 pi centimeters. And the formula, we're trying to find the radius, the formula for the circumference is c equals 2 pi r. So all we're going to say now is that 12 pi centimeters is equal to 2 pi r. I'm going to divide both sides by 2 pi. So these are going to cancel, the pi's will cancel, and 2 goes into 12 6 times. So 6 centimeters is our radius. Okay? And I will do exactly the same thing for part B. Okay? So part B, it says the circumference is 16 meters. And we're trying to find the radius, so I know that the formula that involves the radius is 2 pi r. So I'm going to say that 16 meters is equal to 2 pi r. Still going to divide by 2 pi. So these 2 pi's will cancel with those there. 2 goes into 16 8 times, so I'm going to have 8 divided by pi meters is equal to my radius. Okay. So let's see if we can look at the next one here. It says, if a circle has the dimensions given, determine the circumference. Okay, so we want to find the circumference. So we have two formulas. One of them is pi d, and the other one is 2 pi r. Okay, so for part A we have 18 feet as our diameter. So in part A, they're telling me that the diameter is 18 feet. Because we know the diameter, I'm going to use this formula. C equals pi times 18 feet. So this would just be 18 pi with a feet. Okay. Now part B, we know the radius. The radius in part B is 16 over pi feet. Okay. So because I know the radius, I'm going to use this formula. So C equals 2 pi times my radius, which is 16 over pi feet. Okay. So 2 times 16 is 32. These pi's are going to cancel, so my circumference will just be 32 feet. Okay. All right. So let's see if we can't figure out this next problem here. And it says jet planes can exceed the speed of sound. The Mach number describes the speed of such planes. Mach 2 is twice the speed of sound. And the speed of sound is approximately 344 meters per second. Okay, and it says in part A, if the speed of the plane is described as a Mach 2.9, what is the speed in kilometers per hour? Okay, so we want to find our speed in kilometers per hour. So what we're going to do now is, since we have 2.9, we're going to take 2.9 times 344 meters per second. Okay, so let me take my calculator, turn it on, 2.9 times 344, and I'm coming up with 997.6. Okay, so this is 997.6. This is still meters per second. Okay, we're trying to find our speed in kilometers per hour. Okay, so we're going to multiply this by something because we want to end up with kilometers per hour. Okay, so let's see how we can figure this out. First thing I want to do, I want to convert meters to kilometers. Okay, so I know from, let's see if we can find it, come back over here, we should have it somewhere. Let's see, where was it? When we get to our, here we go. 1 kilometer is the same thing as 1,000 meters. Okay, so 1 kilometer is the same thing as 1,000 meters. So let's see if we can write that out. 1,000 meters is the same as 1 kilometer. And the other thing we want to do, we want to convert seconds to hours. So let's see if we have a relationship between that. Okay, so didn't we say that 3,600 seconds was the same thing as 1 hour? So again, I'm going to think of this here being over 1. Now I'm going to multiply like this, and I'm going to multiply like this. Okay, so let me move my calculator this way. Let me clear this out. I'm going to take 997.6. I'm going to multiply that by, I'm just doing my numerators, by 1, and then again by 3,600. Okay, equals, got a huge number, divided by, let's see what we're dividing by. 1 times 1,000 times 1. We're just dividing this by 1,000. Okay, and I'm coming up with 3,591.36. So 3591.36, 3591.36. And again, this is in kilometers per second. And I'm going to come back here and notice what it tells me to do. It tells me to round to the nearest whole number. So if we're going to round this to the nearest whole number, right, this is the number that I'm thinking about rounding. I have to look at the number directly to the right of it. It's a 3. It's not a very pretty 3. Let me fix that. It is a 3. Remember, I'm only going to round up if that number would have been a 5 or more, so my answer is just going to be 3591. So right here, we're going to say 3591. Okay. All right. Now, part B says, if the speed of a plane is described as a Mach 3.6, what is the speed in meters per second? Okay, so remember the first thing we're going to do, we're going to take 3.6 and we're going to multiply it by 344 meters per second. Okay, so let me take my calculator, 3.6 times 344, and that's giving me 1238.4. And this is my speed in meters per second, right? Because we were already in meters per second. And again, the directions are asking me to round to the nearest whole number. So this is the number that I'm going to round, but I have to look at that one. Since it's not a 5 or greater, it's still going to say is 1238. So this will be 1238. Okay. All right. Now, let's take a look at the next one here. It says, describe the speed of 3,950 kilometers per hour as a Mach number. Okay, so the first thing, basically the way this problem is written, it's going to be kind of like part A, but going backwards. Okay, so look, I'm going to write it out here, 3,950 kilometers per hour. Okay, the first thing I'm going to do, I'm going to try to convert that into meters per second. Okay, so let's see what we can multiply it by. I want to end up with meters, so I know that 1 kilometer is the same as 1,000 meters. Okay, and I also want to end up with seconds on the bottom, and I know that 3,600 seconds is the same thing as 1 hour. So remember, I'm going to think of this over 1. So I'm going to multiply. Let me move this over a little bit so I can use my calculator. But I'm going to multiply it like this. 1, 2. So let me get my calculator. Let me move it this way so y'all can see what it is I'm doing. So I'm going to take 3,950 times 1,000. Okay, times 1. It's going to be the same thing. Okay, here's my number. And I need to divide that by, if I look at my denominator is just going to be 3,600, right? Because it's 1 times 3,600, which is still 3,600, equals, okay, and I'm coming up with 1,097. So 1,097 point, a whole bunch of 2's, right? Now, remember how we convert something to a Mach number. The way we find the Mach numbers, we're going to take this number here and we have to divide it by 344 because that's the speed of sound. So now, oops, sorry, there we go. Let's see if I can close this one up. There we go. Okay, so we're dividing it by 344, and this one is asking me to round to 2 decimal places. So if I round it 2 decimal places, 3.19. So this here would be Mach speed of 3.19. And here's my Mach number. Okay. All right. The next part here, we have something described as arc length. Arc length describes this distance right here. Okay. And the formula that we have is L, the length, is equal to R times theta divided by 180. So part A. Part A says, find the length of a 75-degree arc of a circle whose radius is 6 centimeters. So I know that my theta, sorry, that doesn't look very pretty, does it? This is the Greek letter theta. I know that's 75 degrees. And we know that our radius is 6 centimeters, okay? So we're going to use our formula, L equals pi times R times theta over 180, okay? So we're going to take pi times 75 degrees times 6 divided by 180, okay? So let me take my calculator. What's 75 times 6? That, let's divide it by 180. We got that, 2.5. So guys, if we want to convert this to a fraction, if I go math, and then I hit number 1, it should convert it to a fraction for me, 5 over 2, okay? So this is going to be equal to 5 over 2 with my pi in centimeters, okay? All right. Now, part B, it says, explain why the length in part A is longer or shorter in centimeters if the radius had been 9. So the question now is, if the radius were changed to 9 and theta was still 75, would the length be bigger or smaller? Well, think about it. Here's our formula, right? Since we're multiplying by the radius, if the radius increases, the length is going to increase, right? So I would say since the radius is being multiplied, as the radius increases, so does the length, okay? And then part C says, can we find that new length now? Of course we can. So we're going to say pi times r times theta over 180. So say pi, we said the length is now 9. Theta is still 75 degrees over 180, okay? And let me take my calculator here. So I'm going to take 9 times 75 is that 675. We're going to divide it by 180. Okay, we can convert it to a fraction. Number 1 converts it to a fraction for me. 15 over 4. So we're going to have 15, oops. Oh, come on, eraser. We're going to have 15 pi over 4 centimeters, right? Boom. And there we go. Okay. All right. Okay, so let's see. This next problem here says, can we list the following in decreasing order? Okay, decreasing order. So what I'm going to try to do in this problem here, guys, I'm going to try to put everything in decreasing order, meaning it's going to be from the highest to the lowest, okay? So I know that so far this might be the biggest one, and I know that this is smaller, and I know that's smaller, right? So I know so far I'm going to say maybe 91 meters, and then maybe 5 meters, and then 4 meters. This is going in decreasing order, right? I'm going from biggest to smallest. So I know that 91 is bigger than 5, and 5 is bigger than 4. The ones that I need to figure out is, what about these here? Can I convert these? So let's think about that one for a little bit. Let's take 500 or 5,115 centimeters, and let's convert it into meters. So look, I'm going to go 1, 2. So right here where my decimal is, I'm going to go 1, 2. So that is going to give me 51.15 meters. Okay, so now right here, I got to put 51, and I'm going to leave it in the centimeters form because these are the numbers I'm working with. But I know now that 5,115 centimeters is going to go there, okay? I'm just scratching out the ones that we've already used, okay? Now, let's do the same thing for 259 centimeters. I'm going to go 1, 2. So here's my decimal point, 1, 2. This would be 2.59 meters. So 259 centimeters seems like it's going to go right there. Okay. And then we still need to convert 973 millimeters. So 973 millimeters. Let me erase some of this mess. And we're going to go from millimeters to meters. So we're going to go 1, 2, 3. So 1, 2, 3. and this would be right here. Let's see. Oops, sorry. This is going to be 0.973 meters, which appears to be the smallest one. So at the end, I'm going to have 973 millimeters, okay? So now let me go ahead and write them so that it looks a little bit neater, okay? So we're going to have 91 meters, then we're going to have 5,115 centimeters, then we'll have 5 meters, 4 meters, 259 centimeters, and 973 millimeters. And this is going to be decreasing order. They're going from bigger to smaller. Okay. All right. So now let's see if we can complete each of the following conversions. So we're going to go from 30 meters, and we're going to want to write that into centimeters, okay? So let me erase some of this mess here. We're going from meters to centimeters. So look, 1, 2. I'm moving my decimal place 2 spaces to the right. So I'll tell you what, let me write it right here. 30, 1, 2. So this is going to be 3,000 centimeters. Okay. Let's take 381 millimeters, and again, we're going to convert that into meters. So 381 millimeters to meters. So we are in millimeters, 1, 2, 3, to the left. Okay. 1, 2, 3. So this is 0.381 meters. Excuse me. Now I'm going to go from 635 millimeters to centimeters. Okay. So we're going to go from millimeters to centimeters. 1 space to the left. 1 space to the left would give me 63.5. And then 0.3 centimeters to millimeters. Okay, so 0.3 centimeters. I'm now going from centimeters to millimeters. I'm moving 1 to the right. So 1 to the right would be 3 millimeters. Okay. Excuse me. All right. So the next problem that I have here says, if one measured an object with both inches and centimeters, which do you expect to be more accurate and why? And so the one that's going to be more accurate is going to be actually the centimeter, because the unit of measure is smaller. A centimeter is smaller than an inch, and so that's why that one's going to be more accurate. Okay. All right, so taking a look at this problem here, it says the diameter of AB of the large semicircle has been divided into 4 congruent segments. Each of the segments is a diameter of a smaller semicircle. Which path is longer? The one from A to B of the large semicircle, or the path of the 4 smaller semicircles connecting A to B? Okay, so let's see if we can figure this thing out here. It says if the diameter from A to B is D, so they're saying this distance here, oops, let me get the red. This distance here, we're going to call that distance D. Then the diameter of each of the smaller semicircles. So then they're asking us now, what would the diameter of each of these little circles be? Each of those little circles would be D divided by 4. Okay? That would be the diameter of each of those smaller semicircles. Then the circumference of each of the small semicircles. So remember, now we're going to find the circumference. And the circumference of a circle is pi times d. But if we're finding the circumference of the semicircle, it's going to be, I'm going to put it like this, semi, it's going to be pi times that diameter over 2, okay? And each of those semicircles has a diameter of d over 4. So pi times d over 4 with the 2 right here, because of that over 2, you can think of it like this. This is going to be pi d over 8. So the diameter of each of the small semicircles is going to be pi times d over 8. Therefore, the path along the semicircle, so what this pi over d times 8, that's that distance. That distance right there is pi d over 8. Now, how many of those little do we have? 1, 2, 3, 4. So for the next part, if we were going to find the path of those, we would have to take pi times d over 8. We'd have to multiply this number by 4. Think about it as 4 over 1. So this 4 is going to reduce with that 8. That's going to give me pi d over 2. So this is going to be pi times d. Oops. This part right here is going to be pi times d over 2. Now it says the path along the large semicircle. So let's come back over here. If we wanted to find this distance, remember the circumference of a circle is pi times d, but we're only finding half of it. So the semi would be pi times d over 2. That would be that red distance right there. Pi times d over 2. Thus, and now we're going to pick the distances here. We're asking, are they bigger, smaller, or the same? Well, I want you to look at what I have here. I have pi d over 2, and here I have pi d over 2. And so here we're going to say they're going to be the same. And you're going to click that little arrow there, guys, and you're going to look for the one that says that they're going to be the same. And it might give you a little bit more information, but that's essentially what we're looking for. Okay. So the next problem says, Shayla says 9 kilometers are equal to 900 meters. Do we agree? So either she's correct or she's going to be incorrect. Okay. So 9 kilometers. Remember, a kilometer is 1,000. So if I was going to convert this into meters, I know that 1 kilometer is 1,000 meters. So these are going to cancel. 9 times 1,000 would be actually 9,000. So my answer here would be A, and you were going to fill in the number 9,000 meters, right? So Shayla is incorrect. She was missing a 0. She was putting 900, and the answer is 9,000. Okay. And that was 13.1.